So this first one's nice. Can't go wrong in this first one. Everything's 2. No.
3.
Right? Is that cool? There's actually 2 questions I ask you on the first one, so. What goes here for part B? What goes here? 7. And sure enough, 7 minus 4 is 3. Check. So yes. Yes.
What did you put in the parentheses? Y or?
Say again, sorry?
In the parentheses number, letter A. Letter A.
Where are we at? Sorry?
Letter A, number 1.
Here.
No, the first one. The letter A.
The letter A. And A is 1, right?
The first
Oh,
one.
part A. Sure.
Part A.
What did I do?
On the parentheses, it's Y.
Okay.
What is it?
All right. What does this mean?
2. Okay.
What about it? What does it mean? That means that what is 2? X is 2. What does this one mean? Y is 2, right? So all I did was I replaced Y with 2. Now, I put parentheses. You could just put a dot in the middle, but I have to indicate multiplication. I can't change the operation by plugging something in. Does that make sense?
Yeah.
When I replace a letter with a value, the operation has to stay the same. I can't just suddenly become math god and change the operation. Okay, I like it. Okay. So down here, you just have 4 problems. That's all. So the first problem says make what? Sorry. I love that reading. So make x1. So 2y minus 1 is 7. And then you solve that little thing. Forget about everything else around. There's a little tiny awesome equation. Add 1 divided by 2, you get 4. Is that cool?
Yes.
Okay. Second problem says what is what?
2 multiply 2.
True, but it says y is 2.
2 multiply.
So when I plug a 2 in, I get 2 times 2. Minus x is 7. 4 minus x is 7. Subtract 4. Negative x is 3. Divide by negative 1. I get negative 3. How are we doing? Is that all right?
Yes.
And then the third problem says to make x negative 5. 2y minus negative 5. That's the part that's really easy to make a mistake. There's a minus in the equation, and the value of x is negative.
Yes. So
So that makes plus, so I subtract 5, divide by 2. And then finally, the last one says to make y 5. 2 times 5 minus x is 7. 10 minus x is 7. Can you guys all see that x must be, I can just see it, x must be 3, right? So if I plot those, 1, 4, negative 3, 2, negative 5, 1, and 3, 5, they look to be all on a straight line that I made. Yeah. We okay? What's up? You all right? What happened? You okay? Oh, shice. Okay. And then here, I would always do these, unless there was a fraction in there, and I want to pick multiples or something, right? So just to cut to the chase, if I put a 0 in there, I get 2. If I put a 1 in there, negative 3 plus 2 is negative 1. If I put a negative 1 in, negative 3 times negative 1 is 3, plus 2 is 5. And then you could just go crazy on the last one. We got plenty of points already. So if I put negative 1 billion in there, I'll get 3 billion and 2 when I put it in. All right, I don't care what the last point was. I've got enough points here to plot, right? 0, 2, 1, negative 1, negative 1, 5, and thank God they look like they all line up. Yes, maybe? So some of you guys might have done a reasonable fourth point. Maybe it fit on your graph. That's beautiful. I love it. So this one here, I on purpose made something happen. So if I want to find the y-intercept, I make x 0. So if x is 0, I get, this goes away, divide by 4, I get y is negative 6. So what point is that? X is 0, y is negative 6. I love it. And then to find the x-intercept, I make y 0. So then I get 3x equals negative 24. Divide by 3, x is negative 8. Guys. So then you get, so what do I want to do specially? I don't want to have by ones because then I would go off my scale. So what's a nice easy scale to make? 2. So I can make 2's all around. 2, 4, 6. 2, 4, 6, 8. 2, 4, 6, 8. So this would be 2, 4, 6. You could do it, Jeff. 2, 4, 6. So then it'd be 0, negative 6. You could do it, Jeff. There it is, buddy. And then negative 8, 0. So then my graph goes, holy crap. Something like that. Make that big. Did anybody do number 4? 4 is definitely freaky. All I say is x must be negative 2. So give me a point where that's true. Somebody give me a point that works here. Give me a point where x is negative 2. Yeah, negative 2, 0. There's a point. Give me another point where x is negative 2. Negative 2, 2. It's crazy, right? Does the equation say shit about y? So this equation has no restriction on y. And remind me, the y-axis controls me going which direction? Up and down. So this line, it should make sense. If I have no restriction on y, I can go up and down like crazy. So if I plot these points, negative 2, 0, negative 2, 2, there's the line. X cannot change. So I can't move left and right. But y can go crazy. So that's why it's a straight up and down line. Yes? Couples, all you need. This is a special case. Any x equals equation is going to be like this. So what's a y equals equation going to look like? Like this. Same idea. Those are two special cases. And that's plenty. I think I've kept you over. So tomorrow the quiz, I'll have the practice test. Next Monday will be review day where I'll have the answer key. Okay. Woo! We survived another quick Wednesday. Hey, we not get the quiz back? Man,
Can 2 points be on the same point?
oh, yeah, because you picked the same input.
I did 0, negative 1.
Oh, no. But you see, all right, so the general idea is if the equation's kind of like already solved for a letter, use the other letter as the input. So when you put it in one here, you didn't realize that we're going to end up with the same.
So say that again, what am I supposed to do?
So, doesn't it make sense? If I put stuff in for x, it's already solved for y. So you see how this one isn't really solved for a letter?
Yeah.
So it doesn't matter who I put stuff in for. This one's already solved for y. If I put stuff in for y, I've got to do work to solve for x. But if I only put stuff into x, it's already solved for y. Does that make sense?
Yeah.
So if it's like this, I'm only going to put values in for x, so I know I'm not going to get any ranges.
Okay.
But then I would put 0, 1, negative 1, and then 2 or 3 or whatever.
Okay.
Cool.
Can I see what you did? I was on another problem. You were doing it over the.
Same thing as you. I picked 0, 1, and negative 1, and then I went crazy on the last one, but I put negative 1 billion in. It doesn't matter. Put a 0 in almost always. You put a positive number, you put a negative number, just to make sure you see what the line's doing everywhere.
Mm-hmm.
Yep.
Okay.
But I picked for x because it's already solved for y.
Okay.
Yep.
Will we like the, or this term could do like the quiz tomorrow? Like the earliest time? I could do
Oh, I mean, you can't. Why? You can't save class? Is that what?
No,
it is?
because I have a graduation tomorrow.
If you come to my office hours before,
Like,
yeah.
like what time? Like 7?
Huh?
Because there's one like 7, I think.
But then I'm in there right before this class. You have a class right before this class.
No.
So come at.
This is my
come
own
at
class
12.
tomorrow.
Come at 12 tomorrow.
Yeah, because I mean I have like 10 to 12 to ceremony, and that's like I have like at 10 to 12.
Do you have to leave right at 12:30?
Yeah, I mean I have the ceremony like 10 a.m. to 12.
Oh,
But
then
it-
come right to my office.
It's in TJ, so
Oh shit.
yeah.
Okay. Well, shit. Well then, forget about it. We're just gonna do like anybody missing a quiz. You'll just the next test will take the place
Yeah.
of the missing quiz.
Can I do like early, like
No. I don't like doing that because then
yeah?
to maintain integrity, I have to make other quizzes.